Happy learning! Today we're going to talk about multiplication of matrices. And we're going to start with just a motivating example before we get to defining how to multiply two matrices. Okay, so suppose a store has 30 plasma TVs, 20 LCD TVs, and 10 home theater systems. All right, so this is the inventory of the store. The value for a plasma is $800. Okay, so this question was asked a long time ago, but that's okay. So plasma is $800. LCD is $750, and the home theater is $500. All right, and so the total value of the inventory is, well, it's 30 times 800 plus 20 times 750 plus 10 times 500. Typing this into a calculator, it's $44,000. Okay? And so this is going to be like a motivating example for how matrix multiplication is done. So we could write the inventory as a 1×3 matrix. And let's write the value as a column matrix. Sorry, this is not the inventory. This is the value. It doesn't matter, but here's the value. Let's write the inventory as a column matrix. Having these, like what I originally said, it will give the same result. But so to find the total value of the inventory, what we're going to do is we're going to write our row matrix next to our column matrix. And we're going to go across the row and down the column. So it's going to be 30 times 800 plus 750 times 20 plus 500 times 10. And that's, again, 44,000. And in general, if A is the matrix, so if A is the matrix A1, A2, ... AN, and B is the column B1, B2, Bn, then this product we're going to define to be A1, B1 plus A2, B2 all the way to AN, Bn. Kind of like what we just did here. But instead of stopping at 3, we could stop wherever we want. And this is kind of how matrix multiplication is going to work. We're going to go across a row and then down a column. All right, so let's take a look at the actual definition of matrix multiplication, and then we'll do a bunch of examples. All right, so matrix multiplication. Given an M by N matrix A, and a N by P matrix B, the product A times B is an M by P matrix. All right, let's pause for a second. M by N times N by P. So we need these two values to match up, and what results is you take the first part of the A and the second part of the B. That's going to be the new dimension of our matrix. So it's a M by P matrix C, where the ij entry of C is given by the following. Cij equals AI1 B1J. So you go to the ith row of A and the jth column of B. All right, we're going to continue. AI2 B2J plus dot 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 plus AIN BNJ. Okay, I know this looks intimidating. I'm going to draw out the matrices so we can see how it works, and then we'll do examples. All right, so bear with me. So here's A. Remember, A11, A12, A1N. Let's say this is the ith row, AI1, AM1, and here's B. Okay, to get the ij entry of the product, we're going to go across the ith row and down the jth column. All right, this is how we're going to do it. Just like we did here, where we go across the row, down the column, we're going to go across the ith row in the jth column. That is going to give us one entry in the new matrix. So it's kind of a slow process, but a computer could do this for us. Okay, let's do an example. Okay. So if A is the matrix 3, 1, 2, 0, and B is the matrix 1, 3, 2, 1. Let's find AB. And we're going to find BA. Okay, so your whole life you've thought that multiplication, it doesn't matter what order you do it. But with matrices, it actually does matter. All right, so let's do AB first. So A is 3, 1, 2, 0. B is 1, 3, 2, 1. Okay, the top left entry. We go across the first row, down the first column. So it's 3 times 1 plus 2 times 3. That is the top left entry of this new matrix. The top right entry, so the 1, 2 entry, first row, second column. 3 times 2 plus 2 times 1. Bottom left entry, we do bottom row, left column. 1 times 1 plus 0 times 3. And then the bottom right entry, 1 times 2 plus 0 times 1. Now we got to figure out what these values are. 3 plus 6 is 9. 1 plus 0 is 1. 6 plus 2 is 8. And 2 plus 0 is 2. That's the matrix AB. All right, so now let's try to do BA. And now that you've seen me do the first one, pause the video, try to do the next one on your own. So welcome back from being paused. We go across the rows, down the columns. 1 times 3 plus 2 times 1. 1 times 2. 2 times 0. Okay, for the bottom left, we go 3 times 3 plus 1 times 1. And then for the bottom right, we go bottom row, right column, 3 times 2 plus 1 times 0. All right, and now we'll figure out what these values are. 3 plus 2 is 5. 9 plus 1 is 10. 2 plus 0 is 2. And 3 times 2 is 6. All right, so notice A times B is some matrix. B times A is a different matrix. So we do have to keep track of what order we're doing the multiplication. All right, there's a special type of matrix that kind of behaves like the number 1, right? Just with numbers, if you multiply a number by 1, nothing happens to the number. Well, there's a matrix that has that same property. It's called the identity matrix. So an n by n matrix that has 1s down the main diagonal and zeros everywhere else is called an identity matrix. Okay, so for example, and we use the letter I for the identity matrix. This is the identity matrix when n equals 3. So when n equals 4, there's a different one. When n equals 2, there's a different one. But it's the same idea. 1's down the main diagonal, 0's everywhere else. So it's just 1, 1, 1, 1, 1, 1, 1, 1, and then you fill in the rest with zeros. OK, so let's take a look at an example. So if A is the matrix 4, 13, negative 7, 2, let's show that A times I equals I times A, which is just A. All right, so we want to multiply A to the identity matrix. Then we want to multiply the identity matrix to A. And then ideally, we're going to get this as our answer both times. All right, A times I. That's our matrix here. And we're multiplying by the identity matrix, I. So that's 1's down the main diagonal, 0's everywhere else. And so what do we get? We go across the first row, down the first column. 4 times 1 plus negative 7 times 0. That's just 4. OK, bottom left. 13 times 1 plus 2 times 0. 13 plus 0 is 13. Top right, 4 times 0 plus negative 7 times 1. 13 times 0 plus 2 times 1. That's A. That's the same. That's right what we started with. All right, now let's do I times A. I, again, is the identity matrix. A is the matrix that was given to us. Across the row, down the column, 4 plus 0. I'll do this entry next. Negative 7 plus 0. OK, bottom left, 0 plus 13. And 0 plus 2. So when we multiply on the left by the identity matrix, or if we multiply by on the right by the identity matrix, either way, we're getting the matrix we started with. OK, let's take a look at an application. OK, so suppose we have the following. Suppose we have the following data. So we're going to have 3 different years here: 2010, 2011, 2012, and 3 different types of loans. Okay, and so this is like what a bank lent out. So they lent out business loans, auto loans, and home loans. $63,300 in 2010 for business, $48,305 and $55,110, $20,024, $15,817, and $18,621. And then finally for home, $51,820, $63,722, and $64,105. All right, so suppose this is how much the bank loaned. And so the bank uses 45% of its income on business loans. So this is its income for these various types of loans. %20 from the auto loans, and 30% from its home mortgages. To get its venture capital fund. Okay, and so what we want to do is we're going to use matrix multiplication to find available capital each year. All right, so for instance, the available capital in the year 2010 is 45% of 63,300 plus 20% of this number plus 30% of that number. Add all of those up, that's our available capital in the year 2010. And so we want to do that for 2010, 2011, and 2012. We could set this up as matrix multiplication. All right, so let's make a matrix with our values here, and then we're going to multiply it by these percentages. So we have the income matrix. And we're going to multiply this matrix times a column matrix that's just made up of the percentages. Right? And when we do this matrix multiplication, the top row will tell us the available capital in 2010, the second row will give us the available capital in 2011, and the third row will give us the available capital in 2012, right? Because that'd be 45% of this number plus 20% of this number plus 30% of that number. That's going to be our 2010. And then we do the same thing for the next row, same thing for the next row. So if we type this into a calculator, right, if you have a TI-84, you can do matrix multiplication, or there's just a bunch of matrix multiplication calculators online. If we type this into a calculator, we get $48,035.80 in 2010, $44,017.25 in 2011, and $47,755.20 in 2012. Okay, so matrix multiplication can be used to solve these types of problems. One last example I want to look at is using matrix multiplication to encode or encrypt messages. Okay, and so what we're going to do is we're going to say like A is the number 1, B is the number 2, Z is the number 26, and space would be the number 27. All right, so if we take all of our letters and replace them with numbers, we can encode a message using matrix multiplication. So let's say our encoding matrix All right, so this would be some matrix that you and whoever you're trying to communicate with knows. But no bad actor that's trying to steal your message will know this matrix. So this is something you and your friend have, and anybody who's trying to steal your message doesn't have this information. And so what we could do, let's say we want to encode the message good job. All right, so suppose we want to encode the message good job. We're going to go 2 letters at a time and write each of these 2 letters as a 2x1 matrix. All right, so G is the 7th letter, O is the 15th. So let's write out here. I'll write it a little bit bigger. So suppose we want good job. So it's the 7th, the 15th, the 15th, the 4th. Blank is the 27th, 10, 15, and 2. And so what we could do to encrypt our message is we could take our original matrix A and multiply it to 7, 15. All right, if we do this matrix multiplication, we get 96, 118. So our encrypted message is going to start with 96, 118. It looks like gibberish, but that's good because it's an encrypted message. It should look like gibberish. We're going to talk about how to undo this eventually. So we've done the first 2. Let's go to the next one. Again, we do the matrix multiplication. So it'd be like 45 plus 20 is 65. And 60 plus 24 is 84. All right, and so we could continue this now with the next 2. '81 plus 50 is 131. And 108 plus 60 is 168. And then finally, the last 2 letters is 5572. All right, so if you wanted to send a secret message to your friend that said good job, you could send them this message. And then there's going to be a way to undo matrix multiplication that will then output good job. Okay, so matrix multiplication has a lot of applications in encryption. And so if you want to keep your message safe, this is a good method to use. Okay, well, I hope you found this interesting, and I will see you next time. Bye-bye.